In this video, we are going to talk about the distillation, which is a separation technique. Basically, there are two types of distillation. One we call a simple distillation, and the another one is basically your fractional distillation. And the second category is your fractional distillation. There is a difference between the apparatus setup of the two, and there's also the difference between the what type of mixtures you can separate by these two techniques. So our focus right now is on the simple distillation. Now let's talk about, because the separation technique, now let's talk about what criteria does it depends on, or we can say what principle does it depends on. So it depends on the difference in the boiling point, the difference in the boiling point of its components. So that means that we can separate out the substances or the mixtures which have a difference in their boiling point, a large difference. So large difference can be approximately, which is approximately more or less than 50 degrees Celsius. तो जिन substances के components के बीच में approximately 50 degrees Celsius का boiling point में difference होता है, उनको हम यहाँ इससे separate out कर सकते हैं, right? Apart now, we need to see कि what type of mixtures can we separate, what type of mixtures we can separate from this type of mixtures we can separate. So we can separate basically two type of mixtures. Number one, from a solution, we can separate out the solute and the solvent. Like for example, if we have the sodium chloride solution, or we have a sugar solution, so we can separate the sugar or the salt from the solution, from the water. So that is the one possibility of having the separation. And the second possibility is that if we have the two components or more than two components, a mixture or two or three, and they have a difference in their boiling point more than 50 degrees Celsius, they can be miscible liquids, they can be in a form of a solution, right? So those substances where they have a difference in the boiling point of approximately 150 degrees Celsius, we can definitely separate them by the process of simple distillation. Now let's move on to what exactly are the method of simple distillation. But before we move on to the method, let's have a look at the setup of the distillation. Now when we have a look at the setup of the distillation, we see three basic components of the setup. Number one, we have a distillation flask. Now this is known as this particular apparatus is known as distillation flask. Now, this distillation flask is actually exactly like a round bottom flask, but it has an arm to it, right? So this is a distillation flask, and this distillation flask has an arm to it, right? So we can see that this is known as a distillation flask. इसके अंदर एक arm है, and this arm is attached to a condenser. So this is apparatus number one, and this condenser is apparatus number two, and this condenser is known as your Liebig condenser. Now we have two type of condensers in our syllabus. One is your Liebig condenser. Another condenser is known as reflux condenser. Now in one of the videos on my YouTube channel, I have talked about the difference between the reflux condenser and the Liebig condenser by taking some of the questions from the past paper. So do watch that. What is the difference between reflux, and when do we use the reflux, and when do we use the Liebig condenser? So this distillation setup has got the three basic apparatus. Number one, it has a distillation flask. Number two, it has a Liebig condenser, and the number three is known as your receiver flask. This is your receiver flask. Okay, now all these are attached exactly the same way as they are shown in this particular setup. Now what is there? The distillation flask. We have a mixture of in the distillation flask, which is marked as a blue, and it's basically the seawater. The seawater has a different component in it. It has got a salt and many other minerals in it, and it has a water as well. So we will be having the mixture in the distillation flask. Now, after that, what are we going to do is, now we are going to cork the distillation flask, and we are going to have another very important equipment attached to it. That's a thermometer. Now, when we are fixing the thermometer, we have to ensure that it is next to the arm of the distillation flask, right? So that whatever the vapors are entering into the condenser, they touch the bulb of the thermometer, and the thermometer is able to measure the temperature of the vapors which are entering the condenser, right? So here we have the mixture in the condenser, and then what we do is we fit the condenser and we put the receiver flask below the condenser. Now, one more thing, when we are setting up, we have to, there are two arms to the condenser, there are two outlets to the condenser. Always the lower outlet, right? This is the lower one, is basically where you are letting, where you're attaching it using a pipe, and you're attaching it to the tap, right? So basically you're letting the cold water in through this inlet. And similarly, this is the upper end, is basically the water out. You again attach it to the pipe, and that pipe is draining out the water, and the water is going into the sink because you're draining out that water. Now, why we are having the so this is very important, because we'll be talking about this in the precautions as well. Now let's start the process. What exactly is the process, right? So as I said, K, we are going to have a seawater in this, and in this, then what we will do next, after having the mixture and setting up the apparatus, we are going to heat the we'll start heating. Okay, so this method comprises of three basic process. Number one, we are going to boil the mixture. Then when we are going to boil the mixture, what happens, one of the components whose boiling point is low will start to evaporate. ठीक है, वो evaporate हो जाएगा, वो अपना vapor form में आ जाएगा. So the second process, the second step is that the evaporation of the component whose boiling point is low. Then when the way it is going to convert into the vapor form, it will be attaching, definitely the vapors are going to rise up, and then there is only one outlet here कि सिर्फ आपके पास एक ही outlet है कि vapors are will be forced to move through this arm into the condenser. और condenser में यहाँ से water in है, तो this condenser is made up of two tubes, ठीक है? एक आउटर ट्यूब है इसके अंदर और एक इनर ट्यूब है. इट्स जस्ट लाइक अ रीफिल वाला पेन कि आपके बीच में रीफिल है और आउटर उसके केसिंग है. तो इन द इनर ट्यूब, दिस इज द वाइट ट्यूब व्हिच इज द इनर ट्यूब. In the inner tube you have the vapors moving in. अब इस inner tube से we can see the vapors are entering in. ये vapors इसके अंदर से enter होते हैं, ठीक है? और जब यहाँ से enter होते हैं और outer jacket में आपके पास water flow कर रहा है. Now this is in the outer jacket, you can see in blue, this is the water is gushing into the outer jacket and it is drained out from this end. So what is the purpose of the cold water which is gushing into it? Is basically it is going to condense the vapor which are in the inner tube. और ये condense करेंगे vapors को, vapors will be converting into the liquid, and that liquid form में आपका component 1 जो है वो यहाँ पर आके it will be dropping into the receiver flask. So component 1 will start coming into the receiver flask. So this is basically the process. So let me do the process again. So the process is basically comprised of the 3 steps. The first step is boiling of the component, boiling of the mixture is taking place. So the evaporation of the component whose boiling point is low will take place, and the third step is basically the condensation of the vapors which are entering into the condenser, right? So these are the 3 basic steps. So I'm doing it once again. What are the steps and how it take place? So let's see again. So what happens here? First of all, the mixture will start to boil here. Then after the mixture start boiling, it's going to evaporate as the vapors. So evaporation will take place. Now what will happen? The vapors will be entering the condenser. After entering the condenser, right? Now, what will happen next after entering the condenser? The cold water, which is circulating in the outer jacket of the condenser, is actually going to condense the vapor which are in the inner jacket. And here we are going to have the component A, the whose boiling point is low, in the liquid form, and that will be collected into this receiver flask. So this is how we will be separating the first component. Then what will happen that after some time we'll stop seeing this drops falling down. So that is an indication that अब आपका सारा का सारा liquid component A का जमा हो गया है, and now that gap is indicating that we are not left with any more liquid A or component A. So what we need to do is we need to have another receiver flask, a fresh receiver flask for the component B. This is one indication that when the drops will stop falling. And the second indication is that the thermometer, we have to keep a close check on the thermometer readings, right? So when the first vapor, the component 1, is going to come into the receiver flask, there is going to be fixed reading shown by the thermometer. Let's say आपका component A और B जो है, component A का 78 डिग्री सेल्सियस टेम्परेचर है, component B का 115 डिग्री सेल्सियस टेम्परेचर है. तो आपका जब component A आ रहा होगा तो आपका thermometer is going to show you 78 degrees Celsius temperature. Then after some time the liquid will stop falling, and then we can see there is a rise in the temperature. और अब जो rise in the temperature हुआ वो अब आपका कितना होगा 115. Slowly and gradually the temperature will rise to 115. So that is an indication, the change in the temperature readings is an indication that now my second component is about to start. और जैसे 115 आएगा तो जो आपका जन कंपोनेंट का जो बी कंपोनेंट है उसके वेपर्स, वो उसका जो लिक्विड होगा, ठीक है, वो कंपोनेंट जो होगा वो वेपराइज होना शुरू हो जाएगा, क्योंकि थर्मीटर इज इंडिकेटिंग 115. दैट मींस नाउ द बल्ब ऑफ द थर्मीटर आर टच्ड बाय द वेपर्स ऑफ बी. अब वो वेपर्स जो हैं वो एंटर होने लगेंगे इनटू द कंडेंसर, और अब उनका कंडेंसेशन स्टार्ट हो जाएगा. तो थोड़े गैप के बाद आपको क्या करना होगा, यू हैव टू रिमूव दिस फ्लास्क and you have to replace this flask with a fresh flask, a new flask in which you can collect the component B. ठीक है, तो इस तरह से आपका component A और component B जो है वो आपने separate out कर लिया from this particular mixture. ठीक है, इस मिक्सचर से आपने कंपोनेंट ए और कंपोनेंट बी आपने सेपरेट आउट कर दिया. सो दिस इज द मेथड वेयर यू हैव अ बॉइलिंग ऑफ द कंपोनेंट, वेयर evaporation take place and condensation take place. So this is how we perform, this is the method through which we perform the simple distillation. Now we will be talking about the precautions related to this particular process. When we talk about the precautions related to this particular process, there are 5 to 6 precautions over here. The precaution number 1, we are not going to take more than 1/3 of the mixture. Will not take more than 1/3 of the mixture in this distillation flask. The reason is कि आप अगर यहाँ पर ज्यादा liquid लेंगे तो liquid क्या होगा, that is going to boil up. ठीक है, वो बबल अप होगा. जब पानी बॉईल करते हैं तो वो बबल अप होता है, तो देयर आर चांसेस दैट इट्स गोइंग टू बबल अप and will touch the thermometer, or maybe the liquid will start entering into the condenser. So as a precaution number 1 is that we are not going to fill, we will just fill the condenser, the distillation flask. We will just fill the distillation flask with 1/3 of the mixture, right? We will fill the distillation flask with 1/3 of the mixture, right? So that's the precaution number 1. Now, after this, the next precaution will be that we are going to have the anti-bumping granules here. So anti-bumping granules, it's the picture also says the anti-bumping granules. So anti-bumping granules are there in order to have smooth heating or smooth boiling. Anti-bumping granules, right? So we will be using the anti-bumping granules, right, in order to have the smooth eating और स्मूथ बॉइलिंग. नाउ अगेन, अगर आपकी बॉइलिंग जो होगी बहुत ज़्यादा वायलेंट होगी और आप बहुत स्ट्रांग हीट कर रहे हैं उसको यहाँ से, तो उसके अंदर क्या होगा, जब आप हीट करते हैं तो स्पिटिंग भी होती है. ठीक है, यू व्हाट डू यू मीन बाय स्पिटिंग, चींटे भी आ रही होती हैं. सो इन ऑर्डर टू अवॉइड द स्पिटिंग, वी डोंट वांट द स्पिटिंग टू टेक प्लेस, क्योंकि हो सकता है, क्या आपके हो सकता है बी के कंपोनेंट्स दे गो एंड वो आपके थर्मीटर को टच करें, जिसकी वजह से थर्मीटर की रीडिंग्स जो हैं वो आपकी जो है, यू हैव एन erratic reading over there. So in order to avoid any kind of a spitting, we are using for the smooth heating and boiling, we will be using the anti-bumping granules, ताकि आपकी heating जो है वो smooth हो. ठीक है. Then the third precaution will be basically, what are we going to do? That is a very important precaution, the position of the thermometer. The thermometer should be the next to the arm of the condenser. The thermometer should always be placed next to the arm, next to the arm of the distillation flask to which condenser is attached, right? To which condenser is attached. Why we are placing is it there, the reason of placing it there, because that is the only outlet for the vapors. So when they are moving into the condenser, they are touching the bulb of the thermometer, and when they are touching the bulb of the thermometer is able to record the temperature of the vapors which are entering into the condenser. So that is giving us an indication that which component is actually moving into the condenser. So if we are in the past paper, we will see that sometime what happens, the examiner, he gave us an erratic setup, and in that erratic setup, he places the thermometer down there. Okay, it is not next to the arm of the condenser, it is somewhere here. So if the thermometer bulb is down there, so that means we are not able to measure the vapors temperature which are entering into the condenser, but it is giving you the temperature of the vapors, maybe the mixed vapors of A and B. So that is not giving us the right temperature of the vapors which are entering the condenser. So the position of the thermometer is very important, right, in this setup. Then the next precaution we are going to have is basically, so these are the three precautions which are again very important. Coming on to the further next precautions, the fourth precaution, that setup should be corked. So we need to have a rubber bung here, right, so that we ensure that the vapors does not escape out of the setup. Instead, they just are positioned into the condenser. They're forced to enter the condenser. So we are going to use the rubber bung there in order to avoid the leakage of the vapors outside, right? The escape of the vapors outside. That's the fourth point. Coming to the fifth and very important point, the lower end of the condenser should always be the water in, and the upper end should always be the water out. This is a very important precaution we need to take, that the lower end, this particular end, the lower end of the condenser should always be water in, and the upper end of the condenser should always be water out. So the lower end should be connected to the tap, right, and the upper end, there the water drainage should take place, and it should be connected to the pipe which is lying in the sink. The reason is that the lower end of the condenser should have an entry of the cold water, ताकि आपके जो भी vapors में आ रहे हैं वो condense, it ensures that all the vapors they condense out. And apart from that, जब आप नीचे से water को enter कराएंगे तो water outer jacket में pressure के साथ gush होगा, और उसके बाद वो outer jacket को fill करता हुआ बाहर निकलेगा. ठीक है. और रिवर्स ऑफ दिस, अगर हम ऊपर से, अगर फॉर एग्जांपल रिवर्स ऑफ दिस, ये आपसे एराटिक एग्जामिनर जो है वो विद एरर्स यही डायग्राम देता है, और वहां पर ये इसको वाटर इन मार्क करता है और ये वाटर आउट मार्क करता है. तो आपको इंश्योर करना है कि ये एक एरर है. ठीक है. और इस एरर की वजह से अगर मैं ऊपर से वाटर इन लेती हूँ तो यहाँ से वाटर आएगा और इस वॉल के साथ होता हुआ ये ड्रेन आउट हो जाएगा. इट इज नॉट गोइंग टू फिल द आउटर जैकेट, जिसकी वजह से आपके जो वेपर्स हैं वो कंडेंस नहीं होंगे. So this particular thing is an error. So the lower one should always be the water in and the upper one should always be the water out. This is again a very important precaution. In the ATP question, again they ask you what will happen if you are going to cork the receiver flask. अगर आप इसके अंदर receiver flask को अगर आप close कर दें और अगर हमारे पास ये जो condenser है इसके साथ ट्यूब अटैच्ड हो और वो ट्यूब जो है यहाँ पर एंटर हो रही हो, ठीक है, तो इसके अंदर होगा क्या कि आपके जो वेपर्स एंटर हो रहे हैं वो उनका टेम्परेचर अभी भी स्लाइटली हाई होता है, जिसकी वजह से, ठीक है, स्लोली ग्रेजुअली रूम टेम्परेचर पे आते हैं, लेकिन इसकी वजह से यहाँ पर क्या होगा, ये प्रेशर बिल्डअप होगा और प्रेशर बिल्डअप होने की वजह से क्या होगा, जो वेपर्स होंगे दे कैन, if you're going to close it, the pressure build up होने की वजह से the vapors or the liquid, there are chances it will start moving back. ठीक है, तो ये आपकी नेक्स्ट प्रिकॉशन है. अगर आप इसको यहाँ पर कॉर्क करते हैं तो हो सकता है वेपर इंस्टेड ऑफ ड्रॉपिंग इनटू द रिसीवर फ्लास्क, इट माइट स्टार्ट moving back into the condenser and back into the distillation flask, and we don't want. Our purpose is to separate the component, so we are not going to cork or we are not going to close the distillation flask in order to avoid this kind of a thing. And then comes the last precaution, and the last precaution is that if, for example, if you have a flammable liquid, if you have a flammable mixture, अगर आपके पास flammable mixture है, that means अगर आपके पास mixture किसी organic compound का organic substances हैं which can catch fire easily. So what do we do here is that we will be indirectly heating it. हम इसको indirectly heat करते हैं either through the water bath or through the oil bath or through the sand bath. ठीक है, तो हम इस particular mixture को या तो आप इसको heat करेंगे indirectly, right? So we will be indirectly heating this particular mixture either through, if you have a flammable, that's the last precaution. If you have a flammable mixture, then we will be using either water bath, indirect heating. We will be doing indirect heating, ठीक है, indirect heating either through the water bath or through the oil bath or through the sand bath, right? So this means that कि आप इस condenser को किसके कंडेंसर को जो है वो रखेंगे एक वाटर ट्रफ के अंदर, ठीक है, और उसके अंदर डिपेंडिंग ऑन द बॉइलिंग पॉइंट्स ऑफ द कंपोनेंट, अगर आपके बॉइलिंग पॉइंट ऑफ द कंपोनेंट जो है वो वाटर के बॉइलिंग पॉइंट से कम है, इफ दे आर लेसर देन द वाटर्स बॉइलिंग पॉइंट, लेट्स सपोज हमारे पास कंपोनेंट जो सब्सटेंस के उनके बॉइलिंग पॉइंट जो है एक का 70 है और दूसरे का लेट्स से एक कंपोनेंट का 70 है दूसरे का 84 है, सो दे आर लेस देन वाटर्स बॉइलिंग पॉइंट व्हिच इज सपोज्ड टू बी 100. तो अब हम यहाँ पर, और दोनों जो हैं वो सब्सटेंसेस फ्लेमेबल हैं, तो उस सिनेरियो में हम इसको वाटर बाथ के थ्रू हीट कर सकते हैं. ठीक है, वाटर बाथ क्या होता है, एक तरह का ट्रफ होता है, टब होता है ग्लास का जिसका हाई रेजिस्टेंस होती है हीट, राइट? तो उस ट्रफ के अंदर हम इसके अंदर पानी भरेंगे और उसके अंदर डिस्टिलेशन फ्लास्क का टप रख देंगे. लेकिन अगर बॉइलिंग पॉइंट अबव द बॉइलिंग पॉइंट ऑफ वाटर है, लेट्स सपोज अगर हमारे पास 115 डिग्री सेल्सियस एक का बॉइलिंग पॉइंट है और दूसरा का बॉइलिंग पॉइंट है 180 डिग्री सेल्सियस, तो उस सिनेरियो में वाटर वेपराइज होने लगेगा क्योंकि वाटर का खुद तो 100 है, तो ये सब्सटेंसेस बॉइल ही नहीं हो पाएंगे. तो इन दैट सिनेरियो वी विल बी आइदर यूजिंग ऑयल बाथ और वी विल बी यूजिंग सैंड बाथ, क्योंकि ये ज्यादा टेम्परेचर तक हीट अप हो सकते हैं और वो इनडायरेक्टली इस फ्लेमेबल सब्सटेंस को हीट दे सकते हैं. तो फ्लेमेबल सब्सटेंसेस आर नेवर डायरेक्टली हीटेड, they are indirectly heated either through the water bath, oil bath, or through the sand bath. So these were 6 to 7 precautions which we normally take while performing the distillation in the lab. Let's have the recap of the precautions which I have mentioned. There are few of them are here and I'll be adding the rest over here. There should be a continuous cold water supply to ensure the condensation, and the cold water need to enter from the lower end. It need to enter from the lower end which is close to the receiver, right? The lower end should always be your water inlet to ensure the maximum condensation of the vapor so that no vapor they escape uncondensed. So the lower end should be your water in, and the upper end of the condenser should be your water out. Then the next precaution, we need to add the anti-bumping granules. Why? In order to avoid the splashing of the liquid, so that the liquid droplets or does not touch the thermometer in order to give the erratic value. Thermometer is kept or fitted close to the side arm of the where the condenser is fixed or attached. This is very important because then only you will be able to measure the temperature of the vapors which are entering into the flask. Then apart from that, I gave you the precaution that the distillation flask should not be filled more than one third in order to avoid in order to have a smooth boiling. Uske alawa, we talked about that if we have a flammable mixture, then in that scenario we will be going for indirect heating, either through a water bath, oil bath, or the sand bath. And the next one more precaution I gave, that the receiver flask should never be closed. It should never be corked, right? So we are not going to cork the receiver flask, right? Because otherwise the liquid will start moving back into the setup. So these are very important precautions. Time and again, they have been asked in different forms. Either the examiner give you the erratic apparatus setup and ask to make the amendments into it, or he asks you to give in the statement form how you're going to make this setup workable. What are the errors, pinpoint, and give the right uh, way how we can correct it, right? और दूसरा ये होता है कि दूसरी चीज जो आपके एमसीक्यूज में आता है वो है ग्राफिकल रिप्रेजेंटेशन. So this is a graphical representation for the simple distillation where we have a temperature against the volume, right? So आप एक fixed temperature पे, let's suppose आपका component A है, तो डेफिनेटली कंपोनेंट ए का बॉइलिंग पॉइंट जब तक कंपोनेंट ए होगा तो एक फिक्स टेम्परेचर पे आपका कुछ वॉल्यूम आप कलेक्ट होता रहेगा. वो वॉल्यूम हम यहाँ से प्रिडिक्ट कर सकते हैं. वो वॉल्यूम हम लेट्स सी कि कितना है. यहाँ से अगर आपका 5 ml से लेकर लेट्स से 35 ml तक, तो अप्रोक्सीमेटली 30 ml ऑफ योर लिक्विड is basically your component A. उसके बाद फिर यहाँ पर इन्होंने दिखाया है this is where your component B started. तो उसके बाद what are they showing you? They are showing you the shoot in the temperature, the sharp increase in the temperature that shows that here your component B starts coming. So this is a graphical representation of temperature against volume. Now here we have the second graph. In this second graph we have the temperature against time. अब यहाँ पे ये दिखा रहे हैं कि जब आपने boiling start करी तो इस particular temperature पे, which is approximately 100 degree Celsius, आपकी 5, 5, 6, 7, 8, and 9, approximately 4 minutes तक you will use kept on collecting substance A, and the temperature at which the boiling point of the substance A is basically 100. So the first 4 minutes, no liquid was coming into the receiver flask. After the fifth minute, you should know how to read this curve. After the fifth minute, approximately, the receiver flask start collecting the component A for the next 4 minutes, right? So इस तरह की graphical representation भी आ सकती हैं आपकी related to the simple distillation in the MCQs form paper.